The main requirements are that your blockchain implementation be abstract and that it be componentized. So in other words, the consensus mechanism needs to be self-contained and work within the rest of the pieces. But if you don't like that consensus mechanism, you can pull it out, plug in another one, and you can still keep all of the other pieces. Same with, using different storage mechanisms, different SDKs, all that type of stuff. So for example, you'll see in Hyperledger Fabric, it comes with a default consensus mechanism. But you can, they're going to roll out some more, you can write your own, and you can pull it out and plug in a new consensus mechanism without having to rewrite all of the rest of the code and everything else. So if you want to start up an open source blockchain initiative that follow those criteria, you can submit it to the Linux Foundation Hyperledger and try to get, selected. You just got to fit their criteria. They go through incubation and finally working their way up to, release and so on. As with the rest of the Linux Foundation type projects, they've got a fairly standard process for moving things through the overall open source community and making sure that it's tested and agreed to and all those types of things. So that's a high-level background of Hyperledger. So when people say Hyperledger, it doesn't necessarily mean one of those three blockchains, right? It could be Fabric, which is probably the most well-known, but it could also be Sawtooth, it could also be Aroha, and I would expect at some point in the future, additional flavors of blockchain may decide to work within this Linux Foundation project set. So there's a lot of confusion about some of those, right? I hear a lot of people say, oh, Hyperledger Fabric, that's IBM's product. It's not IBM's product. They are one of the major backers, but there's plenty of other people that are involved in it. I'm on a couple of the working groups as well. I have, I'm not an employee of IBM. I've never worked for IBM. And there are, many engineers in non-IBM that are part of the Fabric, development team. Now, some of the confusion comes in, but of course, IBM wants to try to figure out how to monetize this some way or another. So they offer blockchain as a service that then uses Fabric underneath, right? Just like you might say IBM offers, Cloudera or Cloud as a database, right? Or something, you can have any kind of, service. Lots of different companies. Oracle just recently announced that they were going to start using this. And, oh crap, I forgot that. Now we have to do that all over. Okay, all right. I run blockchain as a service using Hyperledger Fabric as well. So in no way are you tied to IBM, but IBM, and it's a common model in open source these days, right? You build the core piece of whatever the open source project is, donate that code to the open source community, work strongly to help maintain that open source project, but then you sell the higher level services, you sell implementations of that service, right? That's where you want to make your money. So it follows the entire open source kind of product line and monetization efforts, but there's nothing that makes you ever have to talk to IBM at all if you want to use Hyperledger Fabric. And in fact, the demonstration here that I'm going to show doesn't use IBM at all. It's all built on my own servers and so on. So we're getting pretty close to time here. I guess we'll give them 2 more minutes. Any basic questions about kind of Hyperledger overall that anybody wants to ask real quick before we talk a little bit more about the demo and what it is that I want to emphasize? Good, that makes it easy for me. So I'm going to get started here a little bit then, I think, because I'm going to talk about it at kind of a high level. And one of the things that I want to talk about, the title of my speech is Whose Data? Our Data. Traditionally in software development, even with cloud-based implementations and so on, it's always been my data. I built the database. I define what the tables are. I define who gets to have access to it. I change it whenever I want. I do the backups. Whatever it is, it's my database and my data. And blockchain, particularly the Hyperledger flavors, are really changing that attitude. Now, I think we're all pretty used to the peer-to-peer concepts in the cryptocurrency space, but how do you apply that to all the non-cryptocurrency spaces? And that's really what I want to try to talk about here. I want to try to emphasize that we really are undergoing a major change, particularly when you look at it from the B2B perspective, right? And so I would say that I think the general assumption is that Hyperledger is going to be focused on a lot more business networks. Again, it's an abstract implementation. You're not forced into that, but that's kind of the high level, focus and thought process is you've got lots and lots of organizations, all different types of organizations, and they currently maintain large, massive databases. And in a large number of cases, the data in one database is supposed to be the same as the data in another database, but it's not for some reason. I've spent a lot of my career actually moving data out of one system and into another system and trying to make them match and the reconciliations. Just take a simple use case. I order 10 widgets from you. There is EDI and so on, but I order 10 widgets from you. I fax you PO, I call it in, whatever it is, but you type 12 into your system, right? Now we've got a mismatch in the data of these purchase orders. And so the amount of money that is spent trying to reconcile those things, not to mention wasted effort, right? You actually ship the 10 widgets to me, but I don't want 2 of them, so I got to ship them back and all the extra paperwork. And then the invoice comes into AP saying 12 widgets, but the PO that I issued only says 10 widgets. Now the accountants are coming down to my office trying to figure out what's right, what's not right. There's a huge amount of lost money and effort in those types of things, particularly trying to reconcile those. So we know the blockchain guarantees that there's going to be synchronicity of data across all the different peers that are running on this network. And I want to talk a little bit about the networks as well. We get a lot of confusion, I think, in definitions and terminology about networks. A lot of people say, oh, but this is a permission network, it's a private network. Those are true statements. So a lot of cases where we want private information, right? I'm buying widgets from you. It's nobody's business but yours and mine. I don't need other people involved. I don't need anybody else's permission before we share data, right? If we're talking about it in a business type context. But I think what's important in there is to differentiate between the network, which is private. In other words, you can't join this network unless the rest of the network agrees. But you can easily make the data all public. There's no reason why I have to necessarily hide the data. That's up to the use case. So that sets a little bit of the background of what it is that we're doing here in this demonstration to kind of get through the concepts of how we build a network amongst however we want to do, however many of us there are in the network. We define what those rules are. We define what it takes to add somebody new to the network. We define what it takes to implement the new smart contracts. We define what it takes to modify or change those smart contracts over time, because it's our network and it's our data that's in there. So in other words, it's not up to just me to decide if I want to add a new column to the record set. I have to get everybody else in the network. Well, I say everybody else. Again, it's an abstract implementation, provides a lot of capabilities. So I'm not stuck with predefined approval mechanisms. I get to define these however I want to, right? So let's just say there's 10 people on the network, 10 organizations on the network, and I can define that in order to write a piece of data or in order to change the network topology, it takes all 10 of us to approve. Or I could say it takes a simple majority of us to approve. Or I could say it takes 2 of those peers and 4 of those peers over there. Whatever it is that makes good sense for us when we define our network and we define what it takes to change our network, or we define what it takes to change our data, that's up to us to decide. We're not tied into simple majorities. We're not tied into any particular definition other than the one that we decide. Now, once we decide, we're tied into that definition, right? And so maybe it's 2/3, if that's what it takes to change the network. Once that's done, once the smart contract's written, once the blockchain is created with that rule set, then it's all self-enforced from there, right? Nobody can override that or change that or anything else. So I wanted to kind of try to replicate that in a real world environment. So there's actually 10 servers that are running this network. And you'll see over there that we've got the front end piece on its own server. We've got 2 peers, and we've got the certificate authority authentication mechanism, right? You have to generate the certificates for all the different users to use. If you think about that kind of in a normal corporate context, that may actually be somebody's LDAP server or some other kind of instance that goes through the certificate authority management process. In fact, that's what I rather expect will happen. Again, with Hyperledger, things have to be abstracted. So I don't have to use LDAP. I can use some other authentication mechanism. I can use some other certificate generation mechanism, whatever it is that works and satisfies us. And now I've kind of replicated that over here with Organization 2. They do fairly mirror each other, but they could be used in an entirely different certificate generation process. Organization 1 might be tied into LDAP. Organization 2 is not tied into LDAP. They might have some sort of other authentication mechanism because this organization controls who gets to log on from their side, right? So in other words, just because you can log into Organization 1 doesn't mean you can log into Organization 2. Yes, sir.
Handle a public interface where there's no certificate being used.
And I'll show you in this example, I just defined a guest or public account, and I actually registered them with both of the different organizations. There's other ways I could do it in code, but I kind of wanted to do it from the front end side. Again, it's an abstract implementation. You tell me how you want it to behave, and there's a way to design that in the system. In our case here as well, I defined the guest account to only have read access, right, which is enforced by the smart contract. It cannot change any data. That might be a common mechanism as well.
One other question I have to step back. Is there a model of how the governance structure of the permission network works? How the peers in the permission network agree on the rules, the contracts?
Well, it's defined at an abstract level, right? In other words, you can write whatever rule you want. Right, and I don't want to go into too many details, but actually in the peers, you have endorsing peers and non-endorsing peers, right? And so as an organization, I might have 10 peers, but 2 of them are endorsers and the other 8 are strictly for my internal use for analytics or lookups and things like that, right? I don't want to put that kind of a load on top of the rest of the peers that do the endorsing and everything. They still have a copy of the ledger, but they're not consulted. Again, that's up to us, how we decide we want the network to work. And it's also up to me as my particular organization. I built these kind of mirror each other, but there could be 4 peers over here. There could be 10 peers in this organization and only 2 peers over there. Now, we generally assume there'll be at least 2, right? I mean, if you're only going to run 1 per organization, it's kind of like, what's the point, really? If it goes down, now you've lost all your access and everything else. It's enough work to build 10 peers. I mean, 10 servers here. I can't build 10,000 times or 10,000 servers for kind of a POC here. But let's get into it in a little bit more detail from the demo side of things, which will hopefully give us a little bit more hands-on example. That's one of the reasons why I built this, to try to go beyond just talking about what does this mean, to kind of really show what this means in a fairly real-world example. So I picked healthcare provider credentialing. I don't know how many of y'all are familiar with that process, but at a high level, the insurance company is not going to pay unless you've got all your certifications in place. So that starts with a medical school has to grant you a degree, right? That's the first credential that you have to have. But just because you have a medical degree doesn't mean you can practice medicine, right? Each state has to grant you permission in the U.S. to practice medicine in that state. But just because you have permission to practice medicine in that state doesn't really grant you everything you need, because in almost all cases, the physician has to actually have admission permissions to a hospital in order to provide many of those services. Even general practitioners, right? Because if you're sick enough and you go to your GP, they're going to send you over to the hospital, right? So you've got to have that hospital side, or you can't do even general practitioner type of diagnosis and treatments. You know, I mean, that doesn't mean they can't maybe, you know, just do an x-ray in the office or diagnose a cold or something, but as part of the overall process, you have to have admission permissions to a hospital. So in the end, if you don't have a medical degree and you don't have the regulator's permission from that state, and you don't have an agreement with a hospital that will allow you to admit patients, then you're probably not authorized to perform that medical procedure, and the insurance company is not going to pay for it. So what I wanted to do here is build this in kind of a, you know, semi-representative environment. So I use some open data, some Medicare data, that, you know, download this. So all of the physicians that are in this database, there's about 750,000 physicians that I loaded in. They're actually all real physician names. The ID numbers and stuff are actually real ID numbers. There's 5,000 hospitals in this database, and they're all the real hospitals, 500 medical schools, and then there's the 50 regulators, one for each state. And then to also kind of demonstrate the overall capabilities, you know, if you're a hospital or you're a regulator, you're not going to have just one user. So I created 2 users for every one of these organizations. So there's 10,000 users that can log into this database, and they all have their own permissions. They all have certain things that they can do, right? So a medical school can, you know, create a degree, but when they create it, you know, I have to make up some rules. It's only for a physician in their state, right? And a regulator can only see physicians and hospitals and medical schools in their state. And a regulator in Georgia cannot grant permissions to a physician in Alabama to practice medicine in Alabama, right? And these don't, you know, match all of the criteria that are going to occur in the physician credentialing process, but they give a good flavor of it here. So just to see if I can break something, I guess. Just to get started, I think I must have really broken it somehow. Uh-oh, I may be back to yelling. Let's see. Yeah, I think I might have busted that one. All right, I guess I'll have to yell for a little bit more here. So just to get started, I'm going to go to, so you'll notice here, this is the Beltane, you know, organization, and this one over here is the Berlin organization, but I'm going to sign on as guest. And to make things easy, in this, you know, open POC, all passwords are the same as the username. Oh, come on, hopefully I get connected. All right, come on, where's my, see if I'm, there we go, okay. I don't know why that one's being slow. Maybe I did something wrong. So when the guest account signs on, they can see physicians, they can see the regulators, they can see the medical schools, they can see the hospitals. Now there's a lot of hospitals and there's a lot of physicians, so I don't return, I guess I'm going to have to stop doing that. I don't return the whole result set. There's 750,000 physicians in here, so if I tried to return all physicians, it would crash everything. But you can pick, like I said, there's a lot of names in here, so you can pick just about anything you want to pick. And you can see that I've got all the states, right? Because this is the guest account, and the guest account can see everything, but it can't change or edit any data. If you want to change or edit data, you have to be logged in as that particular user. Same when we look at hospitals. There's actually a whole lot of hospitals. I don't want to return them all the time, but you can see that if I do a quick search on it here, it'll return, and you know, it's a proof of concept to try to demonstrate things. So as physicians, you have to match on the last name if you do a search. Hospitals, I did that as a regular expression matching, so that you can, you know, do a partial search, trying to demonstrate some of the capabilities here as well. And the same for users. There's 10,000 users, so it's too many to return all of them. I got a few little naming patterns here, right? So all regulators are start with REG, and then the 2-letter state abbreviation, and then A or B based off the user. You know, I'm not gonna, you know, there's information on the info page. There's also information along with the videos that I've posted on YouTube. I'm not gonna bore you with trying to go through all of those. But one of the, you know, a couple of them real quick is just that if you want to find a medical school user, they all start with MS for medical school, and you'll see that returns all of the medical schools. And, you know, you got A and B for each of the medical schools. And then for hospitals, you have to at least do like their HOSP and then like 1 through 9, because again, there's 5,000 hospitals in here, so have to do a little bit of limitations, but you can see that every hospital has 2 users. This displays the password over here as well. It matches the username, so it's a little difficult to fully demonstrate the use of 10,000 different accounts across 5,000 different organizations, all in one demo here. And you know, and of course, normally most users would only have one account. They would only be logging on as one type of user. We'll do our best here to kind of you know, demonstrate those capabilities across the different network. And then for all of these, we'll just pick a physician here. You can double click on the row, and you'll see, you know, more detail about them. And this is the part here that I've got to, thanks, how did you even know?
Yeah, I had a little, you know, a little secret.
Okay, all right. Hey, all right, I don't have to yell anymore. Let's see if I can avoid breaking this one. Maybe I'll stick it in the pocket. That way it won't fall, we hope. So, and again, this is not going to replicate all the things that you would have to do for physician credentialing. But what I've done here, and I'm not really a front-end person as much, but we have an overall status, right? So the basic assumption is you got to have a medical degree, you got to have regulatory approval, and you got to have hospital approval, right? So approval is represented by setting to active or inactive, and then there's an overall status. So if any of your sub-statuses are set to inactive, then your overall status is also set to inactive, and that's controlled by the smart contract. That's controlled by the chain code in Hyperledger Fabric. You know, that's what we as a network agreed when we implemented and built this network and how it would work. So you can see that I've got no choice as the guest account. I can't change any of those values. But if I log off as the guest account, and well, let's see, regulator, California A. I'll log on as a regulator from California and pick a physician last name. We'll just pick Jimmy here in podiatry. Double click on Jimmy. And you can see now, as the regulator, I can change the regulator status, but I cannot change the hospital status, and I can't change the overall status. But if I, as the regulator, now say I'm withdrawing permissions for Jimmy Lee to be able to practice medicine in the state of California for whatever reason. Maybe it expired, maybe he moved, maybe he did something, had his license revoked, whatever it is. Now I can save that, and once you can see that the smart contract then changed the overall status to inactive. So if I double click to go down in there, you'll see that the regulator status, which I as the regulator control, was changed to inactive, but the smart contract changed the overall status to inactive. So, the insurer wants to know if they have everything in place in order to make it legal for them to make a payment on that. And that's why it takes both of these two sub-statuses, so to speak, to be able to define that. And you'll see if I'm over here as the guest account on, well, that side seems to be running slow. It always works this way, doesn't it? You sit there and click on all the buttons while you're waiting for your turn to talk, and then as soon as you get on, it stops communicating properly. Now as the regulator, I can go back in and change this back to active. Maybe just needed to pay his fee for that year or something along those lines. And now when I do refresh of the data, you can see that the overall status has gone back to active from an overall status of inactive. I can replicate that by signing on as the hospital and changing the hospital status. I can go in as a medical school and create a new physician. The smart contract automatically sets all of the statuses to inactive, and then a regulator would have to go in and set them to active, and then a hospital would have to go in and set them to active as well. Yes, sir?
So can you do mass changes?
So the short answer is yes. I didn't build a lot of that in here, but I wasn't going to type 750,000 physicians in by myself. So I've got some data load routines and some things on the side that I can use. And this is more of a POC, right? Right. I mean, but theoretically, yeah, it's no problem. You can define, you can write. I mean, that's one of the nice things about, again, this abstract implementation, right? I mean, I've got several mechanisms depending on the use case. I could put that into the smart contract, right? It could say, if I'm the regulator, go and find me all of the physicians in my state and turn them all to inactive, right? If that's what I want to write the smart contract to do. But I could also write something external, an automated procedure that goes through one by one, says, go get me the full list of all the physicians in my state, and then one by one update them, right? Again, whatever makes best sense for our particular application, our particular use case, our network, and so on.
Could you explain and clarify the benefits of using blockchain here for a web app like this versus not using blockchain?
So, I'm gonna use the provider credentialing, use case here a little bit, but this applies in so many different use cases. But this is actually a reasonable sized problem in healthcare, right? So there's a lot of paperwork that goes on, right? So you want to get, if you're the physician, you got your degree in hand, you move to Georgia, you've got to now apply to the state regulator to get permissions. I don't know the full process. It changes from state to state, but in a lot of cases, you got to fill out some paperwork. You got to take a fax copy of your degree. You got to send it off. Now the state knows you could have faked that degree, right? So now they're going to contact the medical school to get some kind of confirmation that they really did issue that degree. So it's a lot of communication going around between a lot of different systems, and there's a lot of time lag in there. Some of the research we've looked at says it can take 1 to 4 months to get all the credentialing in place for a physician. The same thing that goes on now at the hospital level, right? So the hospital says, yeah, I like you just moved to town. We want to give you permissions to admit to our hospital. So you have to show me your graduation degree from a medical school. You've got to show me that the state regulator in Georgia has granted you permission to practice medicine. And so now there's a number of processes that'll go on to confirm all of that. So in other words, the regulatory permission's only in the regulator's database. And the hospital permissions is only in the hospital database, and the medical degree is only in the university database. I mean, I'm simplifying here to some degree, right? Sometimes, some of that stuff is duplicated across and so on. But here, we're all using the same copy of the ledger. So when I'm the medical school and I say, I just granted you a degree to practice medicine, everybody else on the network can now see that that degree's been granted. They don't have to fax anything over to the medical school. They don't have to ask anybody for confirmation, because we know that it's in this shared distributed ledger that's maintained in these peers across all these different organizations. Does that help answer, or do you still look a little?
No, that's the most common question you're always going to get on permission blockchain, is that there's no use case that you couldn't technologically accomplish more efficiently with an active centralized directory. So
right, but it's centralized directory, then it's mine. It's not our data, right? That's the, agreed, but it's that trust that the blockchain provides that we all know that that data is valid, right? And as well, we're all agreeing to share that data. Because if the medical school puts that degree in their database, they're the only ones that can confirm that, right? So I as a hospital have to go to the medical school. I as the regulator have to go to the medical school. I as the physician have to go to the medical school, and I as the insurer may also have to go. We're all dependent on them to do that.
Technically, those same players got together and said, let's form an association and hire a lawyer or somebody to put up a common directory for us. You could accomplish the same thing.
Technically, that's true, but it's the peer-to-peer trust. It's also got the immutability, right? It's a add-on only, append-only database. We can all see the full history of the transactions. We can see exactly who made those changes, right? When I call the medical school, they may be vouching for it, but they could have had a rogue employee for all we know, right? They don't necessarily have full provenance, to guarantee all of that stuff. I completely agree. There's nothing that blockchain does that can't be done otherwise. But the thing is, all those things are built in and now native and inherent and applied and enforced by the blockchain itself without us having to do those other things, right? So overall, it's cheaper to just use a blockchain than it is to hire all those attorneys and build all those interfaces to all those different systems, or to get everybody to agree on this master database and who really maintains that and owns it and so on. Those things are now just occur naturally because of the nature of a blockchain implementation. But I would say that part of your point, I would completely agree with them. Not every solution needs blockchain, right? So when you look at a particular use case, that's the first question, really, and that's what I advise my clients. Don't just say, hey, look, I heard there's this great new stuff called blockchain, I want to put all my stuff on it. Right? That doesn't make sense. It's never made sense. It's never made sense in many of the other technologies that I've worked with, right? I've had people come to me and say, I want you to build me a database that does this. I'm like, you only want to put 5 values in there. I don't need to build you a database just to hold those 5 values. So there's no different with that in any other technology. And you need to sit down and you need to say, what's the ROI on this? What's the benefit? And that's going to vary through different use cases. So one kind of slightly different example, I don't know how many of you have done work in heavily regulated industries, public industries and so on, but Sarbanes-Oxley, for example, is very important. You have to be able to prove, the CFOs have to sign off that they guarantee they've got a good process in place to guarantee not just the accuracy of the data, but the provenance of the data as well. Right? So companies have spent a lot of money trying to figure out how they're going to prove that. And you can turn on transaction processing in an Oracle database, but it costs you a lot more money. It costs you a lot of effort. You got to hire some really expensive consultants to come in there and do that for you. Right? If you put it on the blockchain, you get provenance out of the box without doing anything. Right? So I would argue that heavily regulated industries may be very beneficial to use a blockchain simply because it provides the provenance. Right? We can talk about immutability, we can talk about some of the other benefits of blockchain, but the provenance may be the most important aspects for some use cases, some industries, and so on. So there's no one answer to any of these things. And like I said, you know, we're in a lot of hype in a lot of ways. You know, you say, hey, I do blockchain, and people say, great, I want to pay you some money to put my stuff on there, but it's not going to pay you in the long run. If I don't advise my clients to say, wait a minute, let's step back a little bit here and think about whether it really makes sense. So, you know, I'm not 100% claiming that it makes sense in this use case. I just kind of picked this one as a good way to demonstrate the different capabilities and how this might work in a large network, and as well, again, you know, work within a large, you know, design that's not just, you know, using a couple of Docker images, and they're not really different domains, and they're not really different certificate authorities, and really play with it, get some performance numbers, and things along those lines. But I believe in it. I believe there's many use cases. Yeah, like I said, you look at the numbers and see whether it makes sense or not.
In our experience, the bedrock reason, I mean, you can argue all day long with different IT professionals about whether they can accomplish all of this more efficiently with conventional techniques. But the argument that persists at the end is whether or not the peers need to be peers. That is, no one has an opportunity to extract monthly rents, control access. That you've got a situation where the correspondent players have to know that they are not subordinated to each other's interests. So that the blockchain with common permissions are not under the control of any central authority. It gets right back to whether you're centralized or not. You know, if you have a low tolerance for a centralized authority, then you've got a good blockchain case. If you don't, you probably don't.
So I agree with that, but that's part of why I built this demonstration, and part of what I want to encourage people to do is to change a little bit of that focus. So, you know, being just a little bit argumentative to some degree, I'm going to say, oh, it's a very centralized network, right? But it's us, it's our network, right? The centralization is not me or you, it's you and I together, right? So, I mean, I think that's a good point. Now, and I'm just going to mention this. This is not something that I myself have been in favor of, but I assume that some organizations will try to implement that, right? So, at least from my background, I know I've done a lot of dealings with Grainger. I don't know how many familiar you are with them, but every large building, every large construction, every large organization, you know, buys something from Grainger. They sell everything from packing tape to wheelbarrow. I mean, it's just a huge amount of stuff, right? They're a big player in that. You could say Walmart or something as well, right? So as of now, right? Forget blockchain or anything else. You want to do business with Grainger, here's the contract, you know, here's our terms. If you don't sign this, you can't buy stuff from us. I expect some large organizations will probably try to do that. They may build their own blockchain and say, you have to get our peers' approval before you can join the network, before you can place an order, and we don't care what you think, right? We're writing the rules. I hope they don't succeed at that, but I expect a few of them to try. I think that they won't succeed because anybody that tries to do that, I'll just start up a much more democratic blockchain and do the same thing, and everybody will come to use a more shared network than the one that Grainger's trying to implement. But certainly the technology makes that possible to attempt to do. And if things are possible to do, I assume some organizations will try to do that. So I think it's a very legitimate concern that people have to, you know, work through that. And we look at what we define as network governance, right, which is all the off-chain definitions and agreements. You know, that's going to be real important to define, right? If somebody comes to you and says, hey, I built this great blockchain network, it's perfect for you, it's supply chain management, all you got to do is sign up here, blah, 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 blah. Don't do that until you understand what the rest of the governance model is controlling the smart contracts, right? Like I said, there's a lot of capability inside Hyperledger to define different parameters on there. In other words, no new peers can join unless all of the existing peers agree. That's one possible rule. It could be anybody can join as long as my peer approves, right? Those are both rules that you can write to define how the network grows and modifies over time. So that cannot, I mean, it's enforced in the chain once you decide what it is, but that decision-making process occurs off-chain. All right, and so you need to understand, you need to work and see what fits the best use case. Now, another side of that is, and you know, a lot of people that are, you know, looking at a lot of blockchain stuff don't always like this, but there's going to be some case for this. If you're a regulator, right, well, you already get to write the laws, right? If you don't abide by it, they put you in jail. So that may very well be at least a semi-legitimate case for where one major player defines the rules and runs the blockchain. You know, I wouldn't necessarily be too happy about it, but I'm not necessarily too happy about some of the way they work with some of those rules now, and that's not going to change probably, right? And to some degree, you know, this one right here is one, right? You cannot practice medicine in the state of Georgia unless the Georgia regulator says you can, right? That's the law, right? And unless I can get the law changed, then you're going to go to jail if you try to practice medicine without the Georgia regulator having given you permissions. So we could, in this network, say that every single approval must get one of the regulator's peers, right? It doesn't sound entirely illegitimate because I want somebody kind of overlooking this process, right? You know, I mean, it doesn't necessarily have to be the state of Georgia, but I want somebody that I trust that's going to actually make sure that the hospital was accredited, for example, right? Because I don't want somebody to just start up a medical school in their basement and start granting degrees to people, and now they're going to be able to start doing surgery on me or something. So, I think that's a key point when we look at some of these permission networks. They're not designed necessarily to provide 100% trust in a 100% trustless environment, right? They're looking for, it's more some of these other use cases, right? So when you're looking at currency, cryptocurrency, that's what we want, 100% trust provided in a 100% trustless environment and world. But, you know, I basically trust the regulators in Georgia not to give people permission to operate on me unless they've got good qualifications, right? So I'm already giving them some level of trust, right? Same with the hospital. When I go into the hospital, same with the you know, all of those things, there's a certain amount of trust that is provided in here. So we're not starting with a 100% trustless environment. There's a bit of trust that's already involved in this particular network. And I think you'll see that across a lot of things, particularly in the organization to organization type process. You know, if I'm Walmart and you're Grainger, I mean, we've already got a little bit of trust, right? I send you a purchase order, you ship the stuff to me, trusting that I'm going to pay you at the end of the month, right? We're not trying to, you know, replace all of that. Now, if you're Walmart or you're Grainger and I'm somebody off the street, the deal might be cash up front, right? Because there's less trust already involved in that network participation and how we define those things. So when you look at the entire world and the entire spectrum of what are different networks, what are different existing networks, what are existing use cases, you will find that same spectrum from 100% trustless to maybe even 90% trust, right? And that's the type of thing that Hyperledger tries to provide the capabilities to do, but it's up to you to define what those needs are. You know, what amount of trust do you have to have? What are the network governance rules? And so some things then become easier, right? We'll look at this, you know, there's only 10 fields that I've got in here right now. So let's suppose I now need to put in county, phone number, whatever it might be. We want to make a change to the data that's required in this database. Well, we see in the Bitcoin world any kind of what kind of trouble it is. I mean, it takes a long time to get consensus for people to approve these things. Some people may not approve, and they may end up having forks and so on and so forth. We define that and it's a much easier process in Hyperledger. So, you know, a standard rule would be once we have network members in place, and once we've established the initial smart contract, if we want to make changes to that smart contract, it requires all the participants to agree. That's a standard. It could be 50% or whatever we want, but let's just say it's 100%. So we send the smart contract to the 10 different people on the network. They look at the code, they say it's good, they sign it cryptographically. Once all 10 members have signed it cryptographically, now we can all implement that on our different peers. Again, that's kind of part of the network governance process. That's going to occur out of band. But something like that could take place within a couple of days. And now we've got an established upgrade to our smart contract that now allows us to gather an extra piece of data on there. So I was going to say I got 5 minutes left, so let's make sure we get into any questions here.
Anytime you run to a software upgrade, depending on the goals you set, if it's 100%, every node has to agree to accept that, or else it's not.
If that's what we decided up front, right? I mean,
When you get up to like 300, 400, 500,000 nodes, that can get very difficult. And then you got to think about starting to lower that threshold. Maybe 90% is the hurdle.
I agree. I agree.
You got to get 90% approval. So getting these upgrades done can be extremely challenging.
I agree, but in this example right here, you're probably going to always get the regulator to say, no matter what, you've got to get my approval, right? I don't care how many hospitals, but maybe it only takes 50% of the hospitals and the regulator, right? Hyperledger provides the flexibility to define those rules, and they can change over time. Like you said, on day one, if there's only 2 of us, we want 100%. I mean, you can't even do simple majority if there's only 2 of you on day 1, right? But on day 3, do I need it to be more than 50%, or do I need it to be 2/3? On day 4, I've got 4 people. On day 5, I've got 5 people, right? So you can change and modify those things over time. Sure.
Are any of these private blockchains being used in production?
So I'm going to say no. There are a couple that claim they're in production. I think they're more like prototypes myself. I mean, there's the diamond one that people have been using, and it might be considered at least semi-production. But that said, there are a large number of Hyperledger Fabric projects that have been underway for the last 6-9 months, and many of those are going to be, quote, going to production in Q1 and Q2 of this year. So I expect a lot of announcements on that front.
There's several fintech, like Yard3, Consortium.
Oh, right, but that's not Hyperledger, and it's still not production at this point. Yeah, but it's not production yet at this point either, right?
Walmart's,
Well, so Walmart did one. Well, they did a prototype, I guess I would say, in particular with China and using the supply chain through the food process. I know they announced that the results were successful. I don't know the full criteria, but now they're going to expand that somewhat. Again, I would still classify that myself as a prototype. I mean, a prototype means you think it's close to production and people are starting to use it and test it, right? And act like as if it is production. I mean, I don't know the numbers. I'm going to guess it's still 0.1% of all the supply chain stuff that, they're involved in. So I mean, again, they're getting real close. But again, you got added complexity here. I mean, look at all the different organizations. It's not, like I said, it's not my database anymore. It's our database, right? So you got to do a lot. I got to get a lot more people to agree, right? If it's my database, I can just put it in, and when I'm happy with it, I can call it production, right? But now we're looking at networks of organizations. We're looking at different types of organizations that have different types of requirements for these live blockchains. So you have to be a little bit more certain up front. Got a little bit more of approval process and network governance, and of course it's a new technology as well. So I think that it makes sense that they're getting really close, but basically still not entirely there.
What was the name of the prototype?
The Walmart one?
Also, that's the Walmart one.
Well, I know Walmart did one with at least China, but I think they had a couple of other countries involved over in Asia, and it was the food supply chain. Yeah, most of the ones that I'm aware of that are announced are, IBM's working on with them. You can do a pretty good search, and in fact, the IBM website's got kind of a PR, search page. And if you go, I mean, they actually got a tag for blockchain, and it'll show you like all of the projects that they've announced. They announced 2, 3, 4. Korean Stock Exchange, I know, is running one. London Stock Exchange announced that they were going to be running one as well. So the prototypes are well underway. They're all running in dev, test, UAT type environments. So, everybody wants to be the first. Everybody wants to claim they're live and in production. They can claim that if they want to. Myself, I think I wouldn't call any of them production yet, but you will see though. 2018 is the year for this, right? You're going to start to see more and more of these projects that have been working on for the last year and a half. They're going to all come online this year.
Yeah, I think a lot of the big players would tell you that the cryptocurrency and ICO hype notwithstanding, the permission blockchains are dwarfed for permission at the end of the day. But that's their opinion. You haven't talked about the consensus validation management methods that you're using, or Hyperledger using.
Well, no, I didn't. And again, so this is Hyperledger Fabric, right? And I didn't want to get too much into the weeds. Again, I'm trying to talk about and emphasize in this, about how the network works, how to think about that and expand your viewpoint from my data to our data. In Hyperledger Fabric, it's really a twofold process at the moment, right? You define what other peers have to endorse your proposed transaction. Right? So if I say it takes one regulator and 12 hospitals, then you as the client send that out. They run it through their copy of the chain code and make sure that it all works and looks good. And then they sign the transaction and send it back to the client. And then the client sends that over to the order side of things. I think I just lost that.
There's a lot of confusion around proof of work.
So this is not even really a proof, so to speak, right? It's an endorsement from the other peers. Fabric, they did this in the .6 release. They took it out for the 1.0 release, and they're going to put back in practical Byzantine fault tolerance. Right, so I don't know if you're familiar. I don't want to get too much into the details of that, but that is an implementation, a consensus implementation that's going to come online here soon enough, and then you can choose what makes best sense when you're using Fabric. But again, like I said, it's a componentizable section. If you want to use Fabric, but you don't like any of the existing consensus mechanisms, you can write your own. Somebody else, as this product suite grows over the years, I'm sure more people will write other consensus mechanisms and so on. Now, I'll touch just briefly on, because it's actually kind of an interesting thing, the Sawtooth version that Intel, their project, donated. They use what they call proof of elapsed time as their consensus mechanism. And it's actually hardware-based. You have to be using an Intel processor. It's built into the Intel processor. And what they mean by proof of elapsed time, basically all the CPUs are talking to all the other CPUs, and the first CPU that's got a free cycle to propose that transaction is the one that gets elected as the leader. So that's a hardware-based consensus mechanism that is the default consensus mechanism for Hyperledger Sawtooth. But again, it's a componentized thing, so if that doesn't fit your use case, but you like the other parts of the Sawtooth implementation, you can still save all the other code and just build your own consensus mechanism in there. So I would say, probably because you're probably thinking this, there's fairly limited choices today on the consensus mechanisms, but there will be more and more of these coming online. And if you don't like what's out there, write your own.
Now, I think it's important because there's a lot of argument about Ethereum versus Hyperledger. It's a big selling point for Hyperledger that you don't have to deal with all that gas and proof of stake or certainly proof of work. The overhead that comes with blockchain repeated in large-scale operations like what you're talking about goes away with something like practical Byzantine.
Well, I completely agree. I'm looking much more at business solutions, large-scale organization solutions, existing networks that are already, fairly private in many ways. I bet half of you didn't even know this stuff was out there, and this kind of a, network and process occurred for physician credentialing. So, there's a lot more areas in the world where there are these huge networks of organizations working together. It may be entirely manual. They may just be sending faxes and stuff around right now, but, that's my major interest, and that's why I picked fit Hyperledger Fabric. But if I were to want a currency, I would want the mining, right? I mean, that provides a lot of benefits in the cryptocurrency space. This is not saying, Hyperledger is not saying that these other use cases are crap and you should never pay attention to them and put everything into Hyperledger Fabric. They're saying that for a lot of use cases, and I would agree with, that's my prediction as well, that 90% of all the use cases are going to need something a lot more like this. But there's never going to be one blockchain to rule the world. It's not going to be Bitcoin. It's not going to be Hyperledger Fabric. It's not going to be Ethereum. There's not going to be any one blockchain at all. There's going to be, I think it's going to follow a lot of the patterns that we see all the time. There's going to be a huge proliferation of blockchains all over the place. And then over time, there'll start to be some consolidation. Over time, people will start to say, oh, that one's a whole lot weaker than this one. So everybody will start to migrate over to there. And 10 years from now, we'll end up in a situation where there's, 4 or 5 major flavors of blockchain, and most every implementation of blockchain uses one of those. That's my general thought process on there. I think we're probably getting close to time here, and I'm sure probably everybody's getting a little bit hungry at this point. Any other last questions people wanted to bring up real quick here? Yes, sir.
Who's doing block production?
I'm not sure what you...
Who's in control of the nodes for Hyperledger?
So there's 2 parts of nodes, right? There's the peers themselves, and then because the consensus part is broken out, right? Orders are actually considered nodes in the terminology. That's the shared node, so to speak. But these are private nodes, right? That could be my node. Yeah, I got you. So it depends, but you and I could go together and decide we want to run a node that we share just between the 2 of us. So there's
have our own chain.
Well, you said nodes, right? So we could define our own. Yeah, we could. I mean, any type. You tell me what your use case and requirements are. I can fit that into Hyperledger somewhere. There's no one way that's enforced across the board for all the different use cases. Thanks, y'all. Appreciate it, huh?